All right, so I will open Xcode and we're going to start talking about new stuff. I'm going to create a new project. All right, so if you remember, we go to Mac OS, then we click here, we go to next, and then we give it a name. Let's say lecture 2, CSCI 250, section 1. You want to make sure that C is selected, and we can go next. All right, here's good. Let me maximize that. We click here once, and let me open my Keynote because I want to try not to write anything on the board. Try to use my Keynote. All right, so I'll be kind of alternating between this window and this window. All right, so I did tell you 2 days ago that we can get rid of all of those parameters. And we know what this does, right? So this one's going to print hello world, and the \n will go to the next line. All right. So let me start by showing you how the RAM looks like. So that's a matrix, and I drew that on the board 2 days ago. I'm going to give it 16 different rows or columns, and let me give it 20 different rows. And I'm going to select that. I'm going to go to cell, select all of them, change that to say that. Okay. So you can think of your RAM as a grid, as a matrix, and those cells are what? Do you remember what we gave those cells the name? Bytes. So we said that each cell in the matrix is going to be a byte. Of course, we know that each byte is going to be 8 bits, right? You remember that. Now, here's another thing that you should know and remember. Those bytes have addresses. So every cell in your RAM has an address. Okay? And addresses start with 0. So I'm going to give them some addresses. I'm going to say 0. I'm going to start here from the bottom right. You can start anywhere, really. It doesn't really matter, but this is a good convention so that that will kind of make things easier for us when we kind of imagine variables here in the RAM. So that's going to be address 1, address 2, and when we get to here, what would the address be here? We have 16 different columns. 15, that's good. And what would the address be here? 16. Is that good? All right, so here's 17. And here, anybody want to try? So we have 16 here, we have 16 here. What would that be? 31. Yeah, 31, not 32, 31, like that. Okay. All right, so this is the addresses of the RAM. Now your RAM also has values. So in every byte, there's a value. This is different than the address. So at every byte, there's a value, and at every byte, there's an address. Okay. So let's kind of make sure that that we understand that. The value in this byte doesn't have to be 31, of course. It's very unlikely that it'll be the same as the address. It could be any value. So let me kind of get rid of those values. And let me go back to my C here. So today, what I want to do is I want to show you how to create pointers. So pointers are variables. What makes pointers unique is that the value inside that pointer has to be an address of another variable. So that's what a pointer means. Okay. So how do you create an int? Can someone tell me how to create an int? Just create an int and give it the value 20. Right. Int c is equal to 20. Okay. So what would this do when it executes? Well, here's my RAM. What it's going to do is going to look for 4 bytes. Why is it going to look for 4 bytes, Matt? Why not 8 or 2?
Take up the space it needs for the end.
For the int, correct. And I showed you that
4 bytes.
my int needs 4 bytes. So let's say those are the 4 bytes. And let me kind of merge them. Let me actually simplify it. Let me kind of use those 4 bytes. Let me merge that. And I'm going to put the value 20 here. Okay? Is that kind of clear? All right. So every variable has a value. It may be kind of unpredictable. If you don't assign it a value, it will have a value, but maybe you don't know what that value is. But also, every variable has an address because it takes space in the RAM. It has an address. So if I ask you, what is the address of this variable that has 20? Can someone guess? 19.
19 in or M through P.
What's M?
Well, I'm using the A.
Oh, well, we don't want to look at those. Okay, so you're saying, what's your name? Austin. So Austin is saying the address of this variable is this cell. Is that kind of what you're trying to say or not really? Yeah. Because each cell has an address. We agreed on that, right? In the previous slide, I told you that each cell has a unique address. We see here, each cell has a unique address. And my int here takes 4 bytes. So there's kind of 4 different addresses for that int. But when I ask about the address of an int, that has to be one number. And this is the first byte of those 4 bytes. That's something that you need to make sure that you remember. Okay? So this int takes 4 bytes. The address of my int is going to be the address of the first byte from those 4 bytes. Are we kind of happy with that? All right. So let me show you how to print that. You can say printf. You can say the value of my variable c is %d \n, comma c. Do you remember that? All right. If you want to print the address of c, then you want to do the following. You would say printf the address of my variable c is %p for pointer, because an address is a pointer, and then \n, comma. You cannot do c, because c by itself refers to the value of c. You have to get the address from that variable. And the way you get the address from the variable in c is by doing the ampersand like that. So the ampersand is going to give you the address of that variable c. So if you hit play, you will see the value of c and you will see the address of c. And the address is going to be in hexadecimal. So this is something that that you need to kind of remember too. All right, you see here what happened? I printed the value of c and I also printed the address of c. This is the address of c. All right, are we happy with that? Yeah, this is the and. This is going to get the address of that variable. C by itself is going to be the value. And when you have this and or ampersand, it'll give you the address of that variable. All right, any other questions? All right, so let me show you how you create a variable of type pointer that points to an int. So what does it mean to create a variable of type pointer that points to an int? It means that we're going to allocate space for that variable, but that variable cannot have a value like 10 or 20 or 30. The value that that variable has to have is going to be an address to some int. And today I'm going to show you why this is very useful. Okay? So let me show you how first you declare a variable of type pointer that points to an int. You do the following. You say int, just like how you declare a variable for int, but then you have this star. And then you say, pointer that points, you can give it any name that you want, to an int. Okay? So what this will do, when this executes, it's going to go to the memory and it's going to allocate some space. How many bytes it'll allocate? why do you think that it'll be 4? But this is not int. The data type of that is not an int. The data type is a pointer that points to an int. So you can guess that it's 4. I mean, it's an okay guess, but you cannot be sure until I tell you. And the correct answer is, how about we use a function that's going to tell us how big that variable is? What's that function, or what's that? It's not really a function, but I told you kind of yesterday or 2 days ago that you can think of it as a function, and that's size of. So here, I'm going to do that. Maybe you should help me here. The size of my pointer that points to an int is % what? LU, that's good. So we know that when we do size of, that's going to return data type long unsigned or unsigned long. All right, \n. And what do I do here? I can do size of, and size of what? I could do that or that, because that's kind of the data type of a pointer that points to an int. Or I could do pointer that points to an int. I can do that too. Remember? I can use the variable name, or I can use the data type of the variable. All right, so let me play that and let me show you what's going to happen. Any guesses other than 4? Anybody wants to make another guess? 0. The size of a pointer that points to an int is 0. No. I'm not going to ask you why you kind of came up, or how you came up with 0. Maybe you have a kind of a good justification, but the answer is no. It's a variable. It has to have some space. So if I hit play, any other guesses other than 0? Okay. All right, so let me hit play. It's not 1. It's 8. So it'll tell you here that the size is going to be 8. You see here, the size is 8. Okay. So what does that mean? That means when this line executes, again, a pointer is a variable, just like any other variable, except that the value of that variable has to be an address of another int. That's something that you have to remember. And maybe I'm glad that I'm recording this, so that this is a kind of critical lecture that maybe you can, if you feel like you need to rewatch it, then you should do that. So I should reserve 8 bytes. Let me reserve those 8 bytes. 1, 2, 3, 4, 5, 6, 7, 8. Let me merge all of that. And that's going to be where my pointer is. I just kind of assume that it's here. Okay. So because a pointer is a variable, what does that mean? It means it has an address. That pointer has an address. Just like this variable 20 that has the value 20, this variable has an address. What's the address of this pointer? Anybody wants to guess? What's the address of the variable that has 20? 16. And this because we kind of agreed that it's going to be the first byte. So what do you think the address of this pointer is? Chloe, you want to try? So this is a variable. All variables have addresses. And what do you think the address of that variable is? Matt, you want to say something? 56? Okay, yeah, I mean, that's maybe, I kind of didn't want you to kind of tell me the number. I wanted you to tell me that it's the address of the first byte. So the address of this pointer is really the address of the first byte. That's kind of what if you understand that, then it's perfect. Do you kind of know that? Did you know that? Okay, that's good. The number, it's fine. I'll let you do the math later. I mean, I'm not really interested in that. But I want you to know that the address of this pointer is the address of the first byte. That's kind of what I wanted you to tell me. All right, so how do we get the address of this pointer? Or we'll do that, but before that, we need to do something else. We need to put a value here. What value can I put, do you think, here? Can I put 10 I told you that we can't put 10. What is the value that I can put here? So remember, it's a pointer that points to an int, which means that the value has to be an address of an int. How many ints do I have? If I go back to my code, how many ints do I have? Only one. I only have C here. So if this were to have a value, it has to be the address of C, because I only have one int here. Okay? So how can I assign it the value of C? Here's how you do that. You say pointer that points to an int equals to the address of C. You know how to get the address of C, right? We did that here. And right now I'm using it here, and I'm assigning it to this pointer. All right, so one thing here that you kind of observe, which is super important, is the star here is not part of the name for that pointer. So I'm just using the star to kind of tell C that this is a pointer that points to an int, but it's not part of the name. And that's why when I assigned it an address, I did not use the star here. Is that clear?
Can you explain that one time?
Right, so I want you to know that this star is not part of the name for the variable. So if you want to print the value of that pointer, you just do that. If you want to assign it a value, say an address of another variable, you just use that. We don't use kind of this star.
So what's the star used for?
Well, if what would happen if I get rid of that? It's just going to be an int. I don't want it to be an int. I want it to be a pointer that points to an int. So I have to tell C somehow that this is a pointer that points to an int, and this is the notation.
So why is a pointer like double the size of like the actual int?
Yeah, that's a good question. Why is the pointer double the size of an int? All right. So let's look at the RAM here. What do you think the values of those addresses are going to be? What do you think the maximum value is going to be? It depends on your size of the size of the RAM, right? If I have 4 gigabytes, then that's going to be up to 4 billion. If I have 8 gigabytes, then it'll be up to 8 billion. If I have 8 gigabytes, it'll be up to a much, much larger number, maybe 65, more than 65 billion. It'll be a very, very large number. So if you want to go to some address that is very, very large, you need more than 4 bytes. Okay, so let's assume that this is 4 bytes. What's the maximum number that you can get to using 4 bytes? What's the maximum number that you can put here using 4 bytes? 2 raised to the power of 32, and that's going to be 4 billion. But if my RAM is bigger, if my RAM is 8 gigabytes, then that means those 4 bytes will not allow you to go further. So you need 8 bytes. And because my CPU is 64-bit, I need 8 bytes because I'm allowed to add more RAM. Although my RAM is 4 gigabytes here, I can add more RAM. I'm allowed to because my CPU is 64-bit. And if I add more RAM, and if the size of my pointer is 4 bytes, then that's a problem. I can only access the first 4 gigabytes of the RAM. Matt?
So the more RAM you add to your computer, the bigger your pointer can be?
Well, you cannot have, your pointer is never going to be more than 8 bytes. And the size of gigabytes that you have will never be, or the size of bytes will never be more than 2 raised to the power 64, which is a very, very large number. So when you have 8 bytes, that's going to allow you to go much, much further than you need to go. But 4 bytes are not going to be enough. I mean, in my case, because I have 4 gigabytes, 4 bytes are just enough. But again, I may add more RAM, and then we would kind of, then it would be a problem. All right, any other questions? Does that make sense? You need to kind of understand that. We'll have to kind of talk about that more in future lessons. But let's kind of continue here. All right, so here I printed the address of C using this notation. Is there another way that I can print the address of C right now? Can I say printf the address of the variable C is %p? I know that because it's an address, it's a pointer, \n. What do you think I can put here? Something other than %c. I can do pointer that points to an int, because that's what I put in pointer that points to an int, right? So here, the value that I put in pointer that points to an int is the address of C. So if I just print pointer that points to an int, it's going to print the address of C. Okay? So you need to make sure that you kind of, again, know that. And if you have any questions, you should ask me. So if I hit play, you will see that the address of the variable C is this, and the address of my variable C is this. It's the same thing. I just used two different ways of accessing the address. The first way was just to get the address of that variable. The other way was to put the address in another variable, which is a pointer that points to an int, and then I print the value of that pointer that points to an int. Okay. Do you have any questions about any of this? All right. So here, let's just say that the address of this one is going to be 16. Well, in this diagram, it will be 16. So if I have this point to this, that means the value of this one is going to be 16. And it will have an address. Again, this is a variable, so it will have an address for itself. Okay. All right, so now I want to talk about something super important, and that's part of the reason why pointers are useful. Okay, and here's the thing that I want to kind of show you. If you have the address of a variable, you can get the value that lives at that address. So what does that mean? That means from this variable, this is a variable of type pointer that points to an int. From this variable, you not only can print the address of C, which we just did, you can actually print the value of C. So you can use that pointer that points to something so that you can print the thing that you're pointing at. And this is key. This is the most important thing that you need to make sure that you remember and understand. Okay. All right. So how do you do that? Well, first of all, let me just do printf. Let me see the value of my variable C using pointer that points to an int is, what do you think that's going to be? Percent sign what? D, because I'm going to print the value of C. Right? That's an integer. And then I'm going to do \n. All right, so are you ready for the notation? It's not pointer that points to an int. We know that, right? Because pointer that points to an int is going to have the address of C. If you want to get the value that lives at that address, you would do this. Oh, nope. All right. And that's what makes pointers confusing, because they use the same notation. We're using kind of stars in two different positions, but they mean two different things entirely. So this one means create a pointer that points to an int. So when you see a star in this kind of context, when you see a star after int, that means I'm telling C that I want to create a pointer that points to an int. Okay? So when you see that, you're essentially telling C that you want to create a pointer that points to an int. When you see star like that, which is in any other place except for kind of that, if you don't see kind of an integer here, obviously this is not a declaration here. What this means is get me the value that pointer that points to an int points to. That's what it means. Okay? And this is called dereferencing. This is called dereferencing, which essentially means get me the thing that that pointer is pointing to. So when you try to dereference something like this, 16, essentially I'm going to go to address 16 and I'm going to get the thing that lives at that address. Obviously, you can only dereference pointers. You cannot say, let me dereference this variable. If you dereference this variable, that means I'm going to take this 20 and I'm going to go get the thing that lives at 20, and that's just not allowed. It doesn't make sense. C is not going to let you do that. Okay? So dereferencing is only dereferencing pointers. So let's try. Let's make sure that kind of we know what that's going to do. All right, you can see that it printed the value 20, which is the value of C. Okay. All right, you can create a pointer of that points to any data type. Let me show you that. You remember char, right? Let me say my letter is equal to A. How can I create a pointer that points to a character? Adrian, how do you think we should create a pointer that points to a character? Exactly, char, because I wanted to point to a character, I would do char, but you don't want to forget the star because it's a pointer. And then you can say pointer to my letter. Okay, can you give it a value? You could. What's the value that you can give it? Correct, it's the ampersand of my letter. It has to be an address of a character, because here I say that I want to create a pointer that points to a character. So that means that the address that you want to give it is an address of a character. I only have one character, and I'm going to use the address of that character. Are we happy with that? All right. What do you think the size of my letter is? Well, you should know that because we did that 2 days ago. What's the size of my character? No, it's not 2 bytes. It's 1 byte. So a character is 1 byte. In Java, a character is 2 bytes, but in C, a character is 1 byte. What do you think the size of this one is? What do you think the size of a pointer that points to a character is? 8? Correct, it's 8 bytes. Because it still needs to go to, any other place in the RAM. It doesn't matter what I'm pointing at. That's going to be an address, and I want my address to go anywhere in the RAM, so I need at least 8 bytes. Are we happy with that? All right, let me show you that, because I know some of you don't believe me. The size of my address pointer to my letter is %, unsigned long, \n, comma, size of pointer that points to my letter. Okay. All right, so we'll play that now. But before that, can you tell me how to print A, but not using my letter, using the pointer that points to my letter? Can someone do that? So here I'm going to say printf, the value of my letter is % what? C \n. And of course, I can do my letter here, but I don't want to do that. I want to dereference. I want to get the thing that pointer to my letter points to. I want to dereference pointer to my letter. Are we happy with that? You see here, the value of my letter is A. And here you can see that the size of my address pointer to my letter is 8. Again, regardless of what it points to, it's going to be size 8. Mm-hmm.
I get size 4.
I'm sorry?
I get 4.
Okay, so that means your CPU architecture is going to... what's your CPU? Is it 64-bit or 32 bits? Even if it's 64 bits, your compiler doesn't allow you to utilize that. So your compiler is kind of decided that I'm going to only use 4 gigabytes, and I'm going to only use 32 bits of kind of your power, your CPU power. So do you know if it's 32 bits or 64 bit? Okay. Is it Windows? Yeah, I think if you go to, it used to be where if you go to right click my computer, it would tell you, kind of right click properties on my computer. it would tell you at least your operating system. And yeah. All right. Okay. Do you have any other questions?
So is there a situation where you would not be able to use just the original variable?
Yeah. There's a situation. So you're asking, what's the point of all of that? Why are we kind of having a pointer that points to something, then dereferencing, and okay, there is a reason, and I'll show you that today. Chloe, you have a question?
No, that was my question.
Yeah. So we will do that today. But there's another question that is, Matt. Yeah, you have something to say?
They're asking in general, what's the purpose of what we're doing?
Sure, why not? I mean, it's a good question. No, I mean, it's not a bad question to ask why. What's the purpose? All right. Now, there's another kind of that is a better question, I think. And let me ask you the question, and let me try to see if you're going to be able to answer it. If the pointer that points to a character is of size 8 bytes, and the pointer that points to an integer is of size 8 bytes. And the pointer that points to a float or double or long, all of them are 8 bytes. Why did we need to specify that pointer points to an int? Why not just say, it's a pointer? That's a pointer that points to something. Why did we need to say, it's a pointer that points to an int? They're all 8 bytes, right? All pointers are 8 bytes. So why not just say, it's a pointer? It's gonna point to something.
This is to be more specific, because I can select something and have to select it.
Yeah, but there's a reason. There's a reason that it's kind of.
Is it because there can be different sizes, so the addresses could be like merged?
Because the thing that you're pointing to could be different sizes, right? You can be pointing it to a character, and the character is 1 byte. You can be pointing to an integer, and the integer is 4 byte. But why is that kind of? What's the implications of that?
There's going to be an address that is taken up by multiple bytes are taken up.
So the address of any data type is going to be the address of the first byte. So it's always going to be the address of the first byte. So the address of an int is the address of the first byte out of the 4 bytes that are used by that int. So not quite. I mean, maybe you're close, but not quite. Any guesses? Sam, do you have a guess? No.
I'm trying to take a stab at it. Maybe if you're pointing to something, so you don't have to cast what you need.
Okay, I mean, close, but I need something kind of simpler first. You want me to tell you? Because when you dereference it, you need to know how many bytes you need to fetch from that address. Right? So here, so let me kind of go back here. So this one is a pointer that points to an int. Okay? If you try to dereference that, what does dereferencing mean? Dereferencing means go to that address and fetch something. But if you don't know what you're pointing at, if you don't know if you're pointing to a character or an integer or a float or a double, then you don't know how many bytes you're going to fetch. And you need to be able to know how many bytes you want to fetch.
So like, for example, if you're trying to fetch a character and you don't know if it's a character, you're going to be pulling more bytes than you should.
Correct. Yeah. If you're pointing to a character and you don't know that it's a character and you try to fetch, first of all, it's not going to know how many bytes to fetch. But let's say by default it fetches 4 bytes. It's a problem. Okay. So the reason why we need to know the data type that we're pointing at, because we want to when we dereference, when we go get that value, we need to know how many bytes we want to fetch. Is that clear? All right. Okay. Please, if you have any questions, you should ask me, because it's crucial that you understand this stuff. And I did tell you kind of at the beginning of this course is that you don't want to kind of fall behind in this course. You'll be in you'll be in a position where you don't know what to ask. You'll be kind of that lost. You wouldn't know kind of how to frame your question, because everything is just. So please ask me questions if you have any questions, Tyler.
I noticed that in the int, the address is 12 hex. So does that mean it allocated 4 for the integer itself? Or?
Oh, that's good. So let's just look at this address. So here, Tyler is saying that he noticed that these are 12 hexes. So how many bytes is a 12 hex? If you have 12 hexes, how many bytes is that? Well, 6. So right. So if you have 12 hexes, each 2 hexes is 1 byte. So that means 6 bytes. But that's kind of odd because the size of that pointer is going to be 8 bytes, not 6 bytes. Okay. And the reason why you only see 6 bytes is not because I'm using kind of those 2 bytes for anything else. The reason is because there's 2 zeros here, and they're not displayed. So when there is a 0 to the left, and when you try to print the value, those zeros are not going to be displayed. But in reality, you should have here 8 bytes instead of 6 bytes. Okay, so you should have 16 different hexes. The reason why you don't see 16 different hexes is because there's kind of two zeros here, or 4 zeros rather. There's 4 zeros that are just not displayed.
So in that chart, in the graph that you drew, 20, the address was 16, but that's not 16 because that's your actual RAM address, not the on that chart.
Correct. So this kind of is telling me about the RAM. Now there's a topic that I will hope that we'll get to. It's called virtual memory, which is essentially a mapping between your actual memory and that, what you see here. But for now, it's okay to think that this is the actual address of the RAM. For now, it's okay to think that. It might as well be. There's a few kind of things that we sometimes abstract just to make kind of understanding a topic easy, and then I'll introduce some things like caching and virtual memory, and then kind of you'll know exactly what this number or what this value references. But for now, it is okay to think of this as the address of the RAM. There's nothing kind of wrong with that. All right. Any other questions? Okay. So let me now show you why all of that is useful. Okay. And to do that, I'm going to have to create another function. All right. So I did tell you that main is a function. Okay. So I can create a similar function, and that function is going to say void, which means that it doesn't return anything. And then I'm going to say print something, and let's say it doesn't take anything. I have those curly braces, and I'm going to just say print if welcome to CSCI to 50, like that. That's just a very simple function. If I want to call this function, I would use the name of the function, which is print something. So I can say print something like that, print something like that. And that's going to go there, and it'll print welcome to CSCI 250. Is that good? All right, so we're happy with that. Let me kind of play it, make sure that we understand that. Let me just kind of return 0 here. You see, it worked. It called the function, it printed that. And the reason why we have functions is because you don't want to keep writing that if you want to call this function many times, right? So if you have a function that does some specific task, the reason why you put it in a function is because you're going to be calling it multiple times, and you don't want to copy all this text, copy, paste, copy, paste. You can just create a function and call it, right? So that's the purpose of functions. Now let me show you another function. And this is where it gets kind of interesting. So let me say let me do void for now. Let me say add 5. And here, I want to pass a value to that function. So in my parameters, I'm going to have to specify the data type, and then I'm going to give it a name, say num, like that. So this is a function that does not return anything because it's void. The name of it is add5, and it takes one value of type integer. Okay. Now, what is this function going to do? Well, this function is going to do the following. It's going to say num equals to num plus 5. That's the name of it is add5, and that's what it does. It adds 5 to num. Is that good? All right. Now here in my main, what I'm going to do is I'm going to create another variable. Let me say int main num, like that, and I'm going to give it the value 10. Right? And then I'm going to call the function add5. And I'm going to pass main num. All right, so why don't you stare at this for kind of a few seconds and kind of think of what's happening here. So I have a variable called main num. It has the value 10. And then I'm calling add5, and I'm passing my main num. My main num is going to num, and I'm adding 5 to num. And then what I'm going to do is I'm going to print main num here. Print if the value of main num is %sign d \n, main num. Are we kind of happy? Okay, so what do you think is happening here?
I'm just printing 10.
So Tyler is saying that we're just printing 10. Why are we printing 10, Tyler?
Because you didn't store the +5 back into the variable.
Yeah, so I did not store the 10 plus 5 to the variable. So what is that doing?
Just adds it and then it just throws it out because there's no return or anything out of it.
Okay.
Nothing else with it.
That's good. So that's a good guess. And you're right. When I print this, it's going to print 10. Okay. Now let me show you what happens. Let me kind of play it first if you want. And then let me show you what's happening. All right, so you can see that it printed 10 here. Okay. All right, so let's go back to my RAM. And let me kind of, okay, so this line, int main num, is going to, allocate space, 4 bytes, because it's an int, and it's going to put 10 in it. And let me just say, that's the 10. Okay? Now, when you do this, what's going to happen is this 10 is going to be copied to another variable with a different name, different location, different address, entirely different variable. And that variable is called num. Okay? So when this executes, I'm copying the value of main num, which is 10, and I'm putting it in another variable. So what does that mean? That means there's another variable here that's called num, and that num is going to have the value 10. I copied it. So I copied the value of this variable back to here. Is that good? So then, my next line is going to be num equals to num plus 5. So that means that num is going to be 15. You see what's happening here? I did not change main num. I can't. I'm just, dealing with another variable. Is that good? All right. So how can I change main num? So I'd like to pass main num, but I'd like to change it.
Main num equals add5 main num.
All right, so one way would be to kind of change my function and say, you know what, I'd like my function to return something. So I can say I'd like it to return an int. And what is this value that it returns? Is going to be num plus 5. So instead of saying num equals to num plus 5, I'm going to say return num plus 5. And then here, instead of saying add5 main num, that's it, I'm going to do main num equals to main num plus that. Or rather, main num is equal to that. Okay, are we happy with that? So when this function executes, it is going to pass 10 as a copy, but here I'm going to return 10 plus 5, I'm going to return 15, And returning something means that the function call, this function call will be replaced with that value that's being returned. So this function call is going to be 15. 15 is assigned to main num. When I print main num, it'll be 15. And you can see that it printed 15. All right, do you have any questions about any of that? All right, so let me show you another way of doing it using pointers. Okay. All right, so here, can someone think of another way using pointers?
Passing the address of main num.
So you want to send the address of main num. So it's going to copy that address.
Yeah, and make num a pointer.
Make num a pointer, that's good.
And then the star num plus 5.
Yeah, that's good. That's really good. So here's the idea. The idea is I'm going to create another function that doesn't return anything, void. I'm going to call it add5 using pointers. Okay. And then this function add5 using pointers is going to accept a pointer that points to an int. It's not going to accept an int. It's going to accept a pointer that points to an int. How can I make it accept a pointer that points to an int? Int star. That's a pointer that points to an int. Right? Okay. So then, of course, you want to give it a name. Let's give it num pointer. You have to give it a name, right? Just like how you give parameters names, like num, you have to give that a name. All right. So here, let me kind of do return 0 here. I want to call, let me do the return 0. Let me kind of take that, put it here. All right, so what I'd like to do is I'd like to call add5 using pointers. So here, add5 using pointers. What can I pass? When I say add5 using pointers, Sam? Yeah, I cannot pass main num. Is that clear why I cannot pass main num? Because the data type doesn't match. Main num is an int, and this is not an int. This is a pointer that points to an int. Okay, so I can't do that. For me to pass something the same type, I can get the address of main num, which is essentially the value that a pointer that points to an int can have. So I can do that. Why is that useful? If you do that, it'll also copy that address. So here, let me kind of go back and let me show you that. So let's say here, I'm going to say 1, 2, 3, 4, and I'm going to merge all of that. And let's say that my num is here, or main num is here. Okay? When you pass the address of main num, you're still making a copy of that number. Essentially, you're still kind of creating a new variable here, and you're giving it the value 16. So how is that helpful? Sam?
You don't have to return anything. You can just mutate what's inside.
You can mutate. I'd like to mutate main num. How can you mutate main num? By access, by dereferencing it, by access, because I have the address. Once you have the address of something, you can change it. And that's kind of the idea. The idea here is you can make a copy of this. It's fine. You can make any copy you want. That's all fine, because the value of that copy points to an int. And once you have the address of that int, then you can dereference it. You can change it. You can add anything to it. Okay, is that kind of clear? All right. So how can I? So I have right now num pointer. How can I go from num pointer to the thing that num pointer points to? By dereferencing. How do I do that? Star. So every time you do that, star num pointer, essentially you're talking about the thing that num pointer points to. Essentially you're talking about main num. If you do that, you're talking about main num. So you can think of this as main num. So you want your main num to be equal to main num, right, plus 5. You want to add 5 to main num. So this is equal to main num equals to main num plus 5. Except that you cannot say main num equals to main num plus 5 because that's outside your scope. Main num is not defined in the function, so you're not allowed to do main num equals to main num plus 5. The only thing that you're allowed to do is you can send me the address and I can modify it there. You can send me 2 addresses if you want. I can change 2 variables, or 10. I can change all 10 variables without returning anything. Is that good? Do you like that? Not so much. All right. Maybe like next week's assembly. Well, you should like it. And you should know it. Even if you don't like it. So, all right. So let me kind of look at my notes and give you a few seconds to think of questions if you have any. Tyler?
Why did you need the stars in the expression itself?
Here. Those. What would happen if you do this? So let's go back here. So let's say the address of main num is 16, right? It's the address of this byte. And when you call that function, you're passing 16, and 16 is stored here. What would happen if you say main pointer equals to main pointer plus 5?
You'd add 5 to the address.
Yeah, you're kind of adding 5 to that. That's not helping. And also adding numbers to addressees is something that we have to talk about either today or next week. There's something called pointer arithmetic. When you add 1 to a pointer, it's different than adding 1 to an integer. So we'll talk about that either today or next week. But let's just agree that that's going to change this 16. To what? Let's just not worry about that for now. But it'll change that. So that's no good, right? We don't want that. Other questions?
So, why is that better?
Why is that better? Okay, so you're not convinced yet. If you want to change one variable, it's not better. But if you want to change multiple values, you can't do that with a return statement. When you return something, you only return one value. So if you want to change multiple variables, then it's very useful. Also, you need to know that when we talk about arrays. You see, if you remember in Python, when you pass a list, which is an array, and you change that list in the function, the list that you passed will change. Do you remember that? And the reason why this happens is when you pass a list, you're passing an address to that list. You're not making a copy of that list for good reasons, right? Your list could be huge. You don't want to keep making copies of that list. So instead, you're going to send the address. But you don't kind of explicitly say send the address. It'll automatically send the address. It'll know that it's an array, it's a list. I'm going to send the address, and then we can modify that list, which will modify the original list. So for you to kind of understand how to change lists, which is of course crucial to write code, you need to kind of understand pointers and how pointers change and functions. So yeah. All right, so let's talk about, if you don't have any questions, we can talk about arrays for a little bit. All right. So let me kind of here return 0. All right, so I want to create an array. One thing that you should know from Python and from Java is that array is a collection of items, In Java, those items have to be the same size. And in Java and in Python, those items have to be stored contiguously. So if you create an array of 10 items, those 10 items have to be next to each other. This is a rule, okay? So let me kind of create an array of 10 items. Okay, I'm going to say int my integer array, and between those square brackets, I'm going to put 10. So what is that going to? That's going to allocate how many bytes? Anybody wants to guess? 40. That's going to be 40 bytes. Because it'll be 10 ints, each int is 4 bytes. That's going to allocate a block of 40 bytes contiguously. So that's kind of hard to do sometimes, right? Because it needs to be contiguous. And when it's contiguous and you need a big space, then it'll be kind of problematic. But for 40 bytes, that's nothing. Okay? And we'll talk a little bit about kind of those issues. All right, so what is that going to do? Well, that's going to allocate 40 bytes. So here, how many bytes do we have here? 16. These are 32, right? Are we happy? Let me change the color of that. All right. Okay, let me see style. Okay, maybe I should do cell.
So the color thing as well.
All right, here's a nice color. So these are 32, and then how many bytes more do you need? 2 or more? 8, so 3, 4, 5, 6, 7, 8. Oh, okay. All right, so these are 4 bytes. The first integer will live here, the second integer will live here, and the third integer will live after that. Okay. All right. So we'll talk about, at some point, we'll talk about Python lists, because there's something that you need to do. You need to know in Java and C and C++. The size of each element needs to be the same. They need to be identical. So that's why in C you can have an array of ints or an array of floats or an array of doubles. They all the same data type, same size. In Python you can have an array of numbers and strings and characters. And we'll talk about that briefly at some point. I'll explain how kind of that works. With Python it doesn't work for C. All right, so this is how you create 10 elements. If you want to assign a value for the first element, you use indexing, and that's just like Python. So you say my integer array 0, that's kind of the first element, equals to 50. My integer array 1 equals to 60, maybe. My integer array 2 equal to 20. And the highest number that you can specify here is what? 9. Because you go from 0 to 9, these are 10 elements. Okay? Okay. So let's do some interesting stuff. Now, let me try to print a few elements. Let me say printf the value of the first element is % what? D \n, comma, my integer array 0. Okay, you can see that it printed 50. Okay. All right, so here's something that is super important, and I'll repeat that next week, but I want you to kind of know it. Is that when you create an array like that, what happens is this space is allocated, and then the name of my array, my integer array, is going to be a pointer that points to an int. And that int is the first element of your array. So what that means is there's going to be a pointer. So there's going to be a pointer 1, 2, 3, 4, 5, 6, 7, 8. I'm going to give it another color. Oh, here's another color. Let me merge that. So this pointer is going to have the name, my integer array, and the value of this pointer is going to be the address of first element in the array, which is going to be the address of that, right? Because the address of the first element is the address of the first byte of that element, and that's going to be the very first byte of your array. Let me kind of give it like that. Okay. Are we happy with that? A little bit, not so much. Okay, so this is an address. This is, let me kind of write that here. Let me kind of, it's called my integer array. Is a pointer that points to an int, and it points to the first element or first int in my array. So that's something that you need to remember. So what do you think will happen if you try to print this name, my integer array? What do you think if I just say printf with the right format specifier, printf my integer array? It's going to give me the address. Because I just told you that my integer array is an address that points to the first byte of the first element of your array. So if you want to print that without kind of specifying those indices, if I say printf the value of my integer array is, which format specifier should I use? What's that, Matt? P. Yeah, because it's a pointer that points to the first byte. So I can say my integer array. Okay, so I'm going to hit play, and I'm going to show you the address of my array. That's the address of my array, or the address of the first element of my array, or the address of the first byte of the first element of my array. They're all the same thing. All right, so here's a good question. What do you think will happen if I try to dereference that? So again, my integer array is a pointer that points to an int. That's key here. And the thing that it points to is going to be the first byte of my array.
Would it give you the value of the size of the array?
The value of the size of the array. No.
The array,
It'll give you the value of the first element. Because it points here. The value of this variable, which is a pointer, points here. And when you try to dereference that, the first question that C needs to ask is, what are you pointing at? What's the data type of the thing that you're pointing at? And I told you here that I'm pointing at an int. And because I'm pointing to an int, I'm going to fetch 4 bytes. And then I'm going to print the value of those 4 bytes. Does that make sense? All right, so here, I'm going to show you that. Printf the value of the first element in my array is %d\n, comma, dereference my integer array. Just dereference it. Let me hit play. Okay, it's 0. Why is it 0? I thought it's 50. Oh, we did the 50 after. Right, we assigned it 50 after we printed it. So maybe you look like you want to leave. Maybe I want to leave too. Kind of making all mistakes. All right, so here I should assign it 50 first, and then I can print the value of the first element, right? You know that, so So here you will see that it's going to print 50. When you dereference the first element, it'll print 50.
Did it initialize all elements to be 0?
That's a good kind of observation. C, it depends on the compiler. You don't want to ever kind of assume that it does any of that, but my compiler does that. You always want to say that it's unpredictable. We don't know what the values are, unless you explicitly do that.
Explicitly specify what the value is.
Correct. If you want them all zeros, you have to loop through all of them and give them all zeros. All right. Do you have any questions about any of that? I hope you've been kind of paying attention and you haven't kind of been relying on the fact that I'm going to post the video. I think the video is going to be, it's going to work. It'll be fine, but your time is valuable, right? You don't want to kind of spend time here and then spend time watching the video.
The name of the array is kind of a shortcut to the first element. Are there shortcuts to other elements?